Good evening. Today we are going to do few numericals based on law of conservation of angular momentum. So this is a formula to find the law of conservation of angular momentum. Here the moment of inertia has to be used as I and it is measured in kg meter square. Angular velocity will be given in radians per second. Respective units you have to keep in mind. So starting with your first question. Here the question states that a small block is rotating in a horizontal circle at the end of a thread which passes down a hole at the center of tabletop. So you have to imagine the block is rotating in a horizontal circle and the end of the thread is passing down through a hole which is at the center of the tabletop. This system is rotating at 2.5 rotations per seconds in a circle of 30 centimeter radius. So you have to assume that it is rotating like this in a circular motion. So what will be the speed of rotation when the thread is pulled inwards to decrease the radius from 30 to 10 centimeter? So here I will find the angular momentum. As I know the formula of angular momentum, L is equals to I omega. To get the value of omega, I have been given the value of frequencies. So the first frequency 2.5 rotations per seconds is with respect to the radius 30 centimeter. The second rotation frequency is not given but the radius is provided. Let it be. As we have to apply the conservation of angular momentum, we have L1 is equals to L2. So if I substitute the formula, it will be I1 omega 1 is equals to I2 omega 2. Then moment of inertia I is represented as mr square. So the respective formula has been written here, and the frequency, that is angular frequency omega, in terms of frequency is given as 2 pi mu. So we have 2 pi mu 1. Now substitute all the values, you will automatically get the value of mu 2, which will be the speed or the frequency of rotation when the thread is pulled inwards. Okay, coming to the next question. This question states that a star of mass twice that of the solar mass and radius 10 to the power 6 kilometer rotates about its axis. So mass is given and your radius is also provided with its angular speed, that is omega is also provided to me, that is 10 to the power minus 6 radians per second. I have to find the second omega 2, that is angular speed of the star when it collapses to a radius of 10 to the power 4 kilometer. The solar mass is given as 1.99 10 to the power 30 kg. So this solar mass has to be used. Where I have to use it? A star of mass twice it is written. So there I will use. So first of all, since it is asking me to find the angular speed of the star. So what is star? Star क्या है आपका? It is in the form of a, क्योंकि moment of inertia चाहिए तो star किसके form में है? Is it a solid? It will behave as a solid sphere or it will behave as a ring? That we have to decide. So on deciding that, what I find? It is not a ring. So the moment of inertia for those kind of bodies will be 2 by 5 mr square. So if I substitute the formulas here, 2 by 5 mr1 square omega 1 is equals to 2 by 5 mr square omega 2. Then m will be cancelled out. 2 by 5 will be cancelled out. The equation reduces to this one. One radius is given, another radius is given, omega 1 is given. I am using this one. Now there is a question why the solar mass is provided and why we are not using. We will not use because in this the same star being reduced to a smaller size because of the inward gravitational force. So there is no use of mass. Suppose if they are asking a different question with this same respect and the two different bodies will be given, then you have to take in consideration the mass. Here there is no requirement of mass because mass will remain as it is. So it will cancel out. Now coming to the next question. This next question states that it is an important one. So do it twice at least. The earth were to suddenly contract to the size of its present radius without any force. So what will be the duration? Would the day be decreased? Assume the earth is a perfect solid sphere, and already they have provided. The same here also. The star is not a ring or a circular disk, it is a solid sphere. Hence I is equals to 2 by 5 mr square. Here also they have provided the moment of inertia. Suppose in this question only this part, up to this part is given, you can also calculate the things which are asked here without the given moment of inertia, because always earth is considered as a solid sphere. So what they are asking, the earth suddenly contracts. So let the radius of the present radius of the earth is r1, which is capital R. After contraction, what will become? How it is contracting to its half? It means r by 2. So r2 is r by 2. And when there is a rotation, it is 24 hours time period. The second rotation I don't know, because I have to try to find out this one. Now, conservation of angular momentum, I1 omega 1 is equals to I2 omega 2. Now, since time period is given, so I had a relation of omega is equals to 2 pi upon t. Given hai na? So, I will use this relation for substituting the value of omega I and omega 1 and omega 2. So, once you substitute the formula, you will get the value of T2. It is taken as 6 hours. And what I need, I have to find the decrease in duration of the day, because the earth is reduced by its size. It is half that of the original radius. So, when this will happen, whether the time period will be decreased? Yes, it will be decreased. And it will be decreased by how much hours? 6 hours. It means at that time the earth don't have a 24 hours, it will have 18 hours. Now coming to the next one, it is also a little different variety of question, and I think it is an important one, because here a concept has been used of volume. What is given? What will be the duration of the day if the earth suddenly shrinks to 1 by 64th of its original volume? The previous question they have given me the radius contraction. Here they are asking me the volume contraction. So here again volume of the earth, that is it's a sphere, so V is equals to 4 by 3 pi r cube. Then after shrinking it will be 1 by 64th part. Substituting, I will get a relation of the new radius with the original radius. Then conservation of angular momentum I will apply, and then what I am getting? I am getting 2 by 5 mr dash square multiplied by 2 pi by t. Substituting the values, I will get the answer. Similarly, try the 63 as well as 64, and I would like to solve I want you people to solve 1, 2, 6 and 7. This much is enough to understand the conservation of angular momentum and the relations. Okay, thank you.